Welcome, ladies and gentlemen. So what I'd like to do is show you how to write the equation of a line through a point and perpendicular to another. Now, remember, we're going to write the equation of a line in slope-intercept form. So to write an equation in slope-intercept form, we need to make sure we know what the slope is and what the y-intercept is. And it's important that our graph is going to go through a point, but it's going to be perpendicular to y equals 1/3 x plus 3. So it's very important to understand, well, how do perpendicular lines relate to one another? And to do that, it's important to remember also how parallel lines relate to each other. Remember, parallel lines have exactly the same slope, right? Parallel lines, they're never going to touch. Perpendicular lines, though, they do intersect, and they intersect at a 90-degree angle. So therefore, what we call their slopes is opposite reciprocal. They are the opposite sign. If one slope's positive, the perpendicular line is negative. If one line has a negative slope, the other one has a positive slope. Also, the slopes are reciprocals of each other. Remember, a reciprocal of a number is the numerator and denominator flipped. So the reciprocal of 4 is 1/4. The reciprocal of 2/3 is 3/2. Okay? So when we're writing the equation of the line perpendicular to this line, we know that the slope has to be opposite reciprocal. So this slope is, for the line that it has to be perpendicular to, is 1/3. So the first thing I'm going to want to do is identify what my new slope is going to be. The new slope of my new line, it has to be m equals -3. Because -3 is the opposite reciprocal slope of 1/3, which is the slope of the line that I'm trying to write that is perpendicular to it. So we know what our slope is. So what I'm going to do is I'm going to plug it in. Y equals -3. Y equals -3x plus b. Now the issue is we don't know what b is. Okay? Now, it is possible that b could have the same y-intercept as our perpendicular line, but more than likely it's not. So the best important thing to do is to solve for b. Now, how do we go ahead and solve for b? Well, remember, b represents the y-intercept. This is the y-intercept of the line that's perpendicular to it. So we're not looking to just replace 3. What we need to do is we need to find what exactly is the y-intercept that goes for the line that goes through the point 4, 1. So to do that, what we're going to do is we're going to say, all right, well, the point that my graph has to go through is x through y. Because remember, m represents the slope, b represents the y-intercept, x and y represent any point that the line goes through. So I'm going to plug in 4 and 1 in for x and y. When I do that, I now have b isolated. Now I can solve for b. So 1 equals -12 plus b. Add 12, 13 equals b. So now you can see that b, I have now isolated my b. So the equation of the line, in slope-intercept form, we need to know what m is, which, by using the opposite reciprocal slope from my perpendicular line, I was able to attain. And we have to be able to figure out what b is, which, by plugging in my x and my y coordinate into that equation, I was able to solve for b. So now the equation of my line that is perpendicular to y equals 1/3 x plus 3 and goes to the point 4, 1 is y equals -3x plus -13, which is the same thing as y equals -3x minus 13. Okay? So notice that y-intercepts are not the same. Okay? So very common mistake, students will do the opposite reciprocal, and then they'll use that as the y-intercept. Well, it could be the same, but you can't know that unless you plug in those points to verify that they would have the same slope. So make sure you plug in that point. In the next example here, I have y equals -4x plus 4. Perpendicular, we want to write an equation that's perpendicular to that and goes to the point 3, -1. So again, the first important thing I think when dealing with this is to identify the slope, my new slope. So if that's -4, then the opposite would be positive, and the reciprocal would be 1/4. So I have m equals 1/4 is my new slope. Now, rather than using the slope-intercept form, I'm going to use point-slope form. And remember, point-slope form works when you have the slope and a point. So point-slope form looks like this. Y minus y1 equals m times x minus x1. And if you like using this form, or this, the way I did this one, fine. But a lot of, we use points. The reason why we have point-slope form is to solve when you have a slope and a point. The only thing to really understand differently about this one is x1, y1 is going to represent the point that the graph goes through. And y and x are going to represent any point that the graph goes through. So therefore, now I just plug in my slope and plug in my plug in the points that I have. So it's y minus -1 equals 1/4 times x minus 3. Oops, where did I get 3? Oh, yeah, I don't know. OK, so now y minus a -1 is y plus 1 equals 1/4 times x is going to be 1/4 x. You've got to apply distributive property. And 1/4 times -3 is going to be a -3/4. Then I simply go ahead and subtract. Solve for y. Y equals 1/4 x. And then I need to do 3/4 minus 4. So if you do that on your own, if you didn't have a calculator before you, minus 1. I rewrite 1 as 1 over 1. Now I need to get the same denominator, so I multiply by 4 over 4. So I have a -3/4 minus 4/4, which is going to leave me with a -7/4. And you might say, well, that one's harder. Well, guess what? That's because this one had a fraction. If you were to do this problem using that method, you would still have to do fraction operations. So just wanted to cover both bases using slope-intercept form and using point-slope form. All right, in the last one, we have -7, 2 perpendicular to x equals -3. And this one's very similar to the one I did in parallel equations. So the best important thing to do here is when you don't have an equation that's in slope-intercept form, and you can't really understand what to do, the best thing to do would be to graph what it looks like. So let's graph the information we're given. So we have x equals -3. So if x equals -3, then I go 1, 2, 3. And then what we notice is x is always going to equal -3, so that's going to be a vertical line. Then we want to graph the point -7, 2. So 1, 2, 3, 4, 5, 6, 7, and then plus 2. So therefore, we want to write a line that is going to be perpendicular to x equals -3, but goes through the point -7, 2. So if it's perpendicular, that means it has to create a 90-degree angle. And so therefore, it has to be a horizontal line. And that horizontal line has to go through the value of -7, 2, where the y-coordinate is 2. So we want to write a horizontal line that goes through the y-coordinate of 2. Well, if vertical lines is x equals -3, then a horizontal line will be y equals 2. And there you go. So there you go, ladies and gentlemen. That is how you write the equation of a line through a point perpendicular to another equation. Thanks.